Everyone, myself Ral. In this presentation, I'll be explaining about IPv6 challenges and its implementation. Introduction to Internet Protocols. Internet protocols are the rules and standards that govern how data is transmitted and exchanged over the Internet. Like it gives a set of rules how we should transmit the data and how it should be transmitted from one server to another server or one router to another router. They enable devices to communicate with each other and ensure reliable and secure data transmission. It also makes sure that there is a secure transmission between the data, that is, no data is taken up from other users who do not have access to the data and misuse it. It also takes care of that. Understanding internet protocols is essential for managing networks and ensuring seamless connectivity. Types of internet protocols. There are various types of internet protocols that serve different purposes and purposes of data transmission. Some common examples include TCP/IP, HTTP, FTP, SMTP, and DNS. Each protocol has its own set of rules and functionalities contributing to the smooth functioning of the internet. TCP/IP is used for server management. Like if multiple computers are connected to a single server, TCP/IP is used, and HTTP is used to connect over internet. Like that files are transferred from other server in the other end to this our system via internet, and FTP is used for file transfer. It allows file transfer between two devices which are in nearby location and connected to the same network. DNS also is used for computer systems connected to a server. What is IPv6? IPv6 is a new version of the Internet Protocol that helps devices connect and communicate on the network. It was created to solve a problem where there weren't enough unique addresses available for all the devices on the internet. IPv6 has more addresses and better security than the older version IPv4. It also works with new technologies. It's important to understand IPv6 if you work with network security or interconnected devices. IPv4 had limited number of addresses for the devices over the internet. Now there are vast number of devices connected to the internet, and each of the device has to have a unique address so that it can be recorded in the database whenever it is required to fetch details about that device. So IPv6 allows and gives unique addresses for all the devices available on the internet and who try to access the internet. IPv6 is advantage has this advantage over IPv4, that is, it provides unique addresses for all the devices. Benefits of IPv6 over IPv4. Expanded address space. IPv6 provides a vastly expanded address space which allows for the allocation of unique addresses to a multitude of internet-enabled devices, supporting the growth of the Internet of Things and ensuring the availability of IP addresses for future generations. Efficient routing. The simplified packet header in IPv6 heads to more efficient routing, and improved network performance, reducing the burden on routers and enhancing the quality of service for end users. Enhanced security. IPv6 incorporates built-in security features such as IPsec, providing end-to-end encryption and authentication at the network layer, which is essential for securing communication in the modern digital landscape. The first and foremost important advantage is the expanded address space. Like even for the future generations of systems, there are addresses available to allocate to the new systems which connect to internet, and this helped in improvement of IoT, that is Internet of Things, and efficient routing. Since there are unique address spaces, each system can be routed and the packets can be transferred efficiently from one device to another device without any loss, and enhance its security. As it has its built-in IPsec for an encryption, this provides authentication at the network layer itself so that the communication is secure and there is no loss of data. IPv6 addressing and subnetting. Hierarchical addressing. IPv6 addresses are structured hierarchically, allowing for efficient address allocation, improved route aggregation, and simplified network management. Flexible subnetting. IPv6 introduces a flexible and efficient subnetting scheme, enabling networks to be subdivided into smaller and more manageable subnets while accommodating the growing number of connected devices. Auto configuration. IPv6 supports stateless auto configuration, which enables devices to configure their own IP address and obtain their other network parameters without the need of a DHP server. IPv6 implementation challenges. There are three main challenges in implementing the IPv6 methodology: hardware and software compatibility. One of the primary challenges in implementing IPv6 is ensuring compatibility with existing hardware and software systems. Since this is a new method and it cannot be applied to all the hardware devices which are available, this is the first and foremost challenge which we face in implementing IPv6. And the second challenge is skills and training. Deploying IPv6 effectively demands a workforce equipped with the knowledge and expertise to manage and troubleshoot IPv6 networks and applications. Since it is a new methodology and we need a skilled persons who can implement and manage the protocols and who can troubleshoot the protocols easily. Address planning. Properly designing and implementing IPv6 address plans is essential to prevent address conflicts and to efficiently utilize the vast address space of IPv6. Since the length of the address space is very long, we need to plan the addresses and manage it. Compatibility issues with IPv4. Transition mechanisms, interoperability challenges. Several transition mechanisms, including dual stack, tunneling, and translation, are employed to facilitate interoperability between IPv4 and IPv6 networks. The coexistence of IPv4 and IPv6 poses interoperability challenges requiring careful planning and implementation to ensure seamless communication between network nodes. Transition mechanisms for IPv4 to IPv6. There are three mechanisms: evaluation, pilot deployment, and full deployment. Evaluation checks the infrastructure applications of IPv6 deployment. Pilot deployment skills, it is used in small scale and identifying potential users in real world scenarios. Full deployment, it is for the bigger and vast area networks. Security considerations in IPv6. There are two methods of security in IPv6. IPsec integration, which is built in and it offers end-to-end encryption. Address privacy, that is, only the limited data is shown to the users and the rest of the address is hidden. IPv6 deployment strategies. Gradual adoption. IPv4 devices are gradually adopted to new IPv6 methodology and dual stack implementation. Both IPv4 and IPv6 protocols can be used together and it supports this feature. Case studies show that 150K and 150,000 global reach addresses use IPv6 methodology and service availability is 95%. Like still more devices can be used for IPv6 methodology. Conclusion and future of IPv6. Scalability. IPv6 scalability ensures growth and evolution of network infrastructure to accommodate the increasing demand for connected devices and services. Security, it has IPsec and built-in address management system for security. Global adoption. The gradual but inevitable global adoption of IPv6 sets an global next generation of internet technology and innovation features. Thanks for watching. Please like the video.